The next series of sums are integration, and integration has three types of sums. First, the fundamental rule of calculus, then we have integration by parts, and we have integration by substitution. There's another type of integration where we have to integrate partial fractions. For that we have to use the fundamental rule of calculus, the integration of reciprocal and the integration of algebraic exponents. So this particular sum is substitution. For substitution, we need to substitute the Cartesian integral and make it into whatever substitution we have to do. So usually it's u, so u1 to u2 we have to convert the limit, then we have to express the y in terms of u, a function of u, and we have to convert the dx into u. This is done by differentiating the terms that has x in it. So let's start using the substitution u square equals to 2x minus 1, or otherwise means so you have to do it using this. So first of all, we have the limit when x equals to 1, I'm taking the lower limit, u square equals to 2 into 1 minus 1, which is 1. Therefore u equals to plus minus square root of 1. Therefore you take the positive value 1. When x equals to the upper limit is 5, so u square equals to 2 5s are 10 minus 1, which is 9. Therefore u equals to plus minus root over of 9. Therefore you take the positive value, square root of 9 is 3. So the limit has been substituted. The next thing that we have to do, we have to substitute dx. For that we have to differentiate. So we know u squared equals to twice x minus 1. One way of doing this is sending the square to the other side and writing it as a square root and then doing it as an exponent derivative. But better than that, it is easier if you do this using the implicit differentiation. Implicit differentiation, for example, when you have d by dx of y to the power n, the implicit differentiation would be n y to the power n minus 1, again dy by dx. That's the implicit differentiation for this particular sum. So derivative of y square would be 2u, and with this we will have du by dx. If it was y square, it would be 2y into dy by dx, and this is u, 2u du by dx, and this side derivative would be 2. Therefore what we can do, we can write u du equals to dx. So this 2 and this 2 will cancel off, and we can write u du equals to dx. That's the substitution. Let's move on here. Now the substitution is complete, so hence integration, the lower limit is going to be 1 and the upper limit is going to be 3. Dx is good, but before dx we have to substitute x. Now this can be done by sending this minus 1 to that side, it becomes u square, and then dividing by 2. So I can just find an expression for x, so it would be 3, and for x I can write u square plus 1 divided by 2 divided by, so I'm just rearranging this algebraic term and finding an expression for x. Now divided by square root of 2x minus 1. Now if you send this square to the other side, u would be equals to square root of 2x minus 1. That's what we are doing. We're taking this expression and playing with this, so it would be u, and the substitution for dx is done here. Dx equals to u du, so we have u du. So the substitution has been done. So now this would be limit 1 to 3, this u and this u cancels off, so we can write 3 by 2 u square plus 1 du. It's a good idea to take the constant outside. Even if you don't take the constant outside, that's fine too. So 3 by 2 1 to 3 limit, so u square plus 1 du is the integral. So if I integrate, u square is going to be u cubed by 3 plus 1 is going to be u, so this would be 1, limit 1 to 3. Now remember, when we have a limit, there is not going to be an expression as the integral, so it has to be a value. It's going to be a specific numeric value. As we put the limit here, 3 here would be 3 cube by 3 plus this would be 3. Remember, 3 by 2 is multiplied with the entire integral, minus, if I put 1, it would be 1 cube by 3 plus 1. So now by doing the calculation we can write this 3 and this 3 squared, so 27 by 3 is 9. 9 plus 3 is 12, so this would be 3 by 2, 12, minus this would be 1 by 3 plus 1, so 3 1 the 3 plus 1 is 4 by 3. 4 by 3, so that would be, let me do it here, so 3 12 the 36, 36 minus 4 is 32 by 3, so 3 by 2 into 32 by 3, this 3 and this 3 cancels, 2 into 16 is 32, so the integral is 16. This particular sum is shaded region, so when you have a shaded region it either has to be an area or a volume. Remember, space, shaded region represents a space, flat space. So if it's a flat space, we call that flat space area. If it's a solid space, we call that a volume. So flat space or solid space, that's how it is going to work. Shaded region is always a flat space. So when you have to find the volume, what they do, you have to imagine that this flat space is being rotated on the x-axis or on the y-axis, but usually on the x-axis, so that it forms an imaginary solid. Now this particular question is about the region R is rotated through 360 degree, meaning in a complete circle, to form a solid, an imaginary solid. That means this picture is going to look like this. When you have this, and this is the picture, and the region is 1 2 3, this is the region. Now if you rotate it on the x-axis, it's going to be some sort of a solid like this, like a bell with the top cut off. Remove this. So this is what the solid looks like. When you're finding the volume, you're actually finding the volume of this solid. The rule for finding the volume, think of this like a cylinder. Whenever you rotate something, it's like a cylinder, and this is the x-axis of the cylinder from limit A to limit B, and this is called dx, and this is the radius of the cylinder is the y. So the volume of the cylinder is pi r square h. By integration we do this, limit A to limit B, pi, radius is y squared, radius is squared, height is dx, so pi y squared dx is how you do the volume. For this particular sum, we know the limit is from 1 to 3, so we write y equals to 1 to 3 is the limit, pi y squared dx. So that's the Cartesian rule for the volume. Now we can plug in the value of y. It's always a good idea to bring the constant pi. Pi means 3.14. If we bring it outside, it will be an integration of 1 to 3 x e to the power x whole square dx. So this would be pi 1 to 3 x squared e to the power 2x dx. So that's the integral that we have to do. Now they will mention in the exam by parts, but you know from the common sums that x squared e to the power anything, that's by parts. So they have mentioned use integration by parts to find this. Now the integration by parts formula is given by, if you have to integrate from limit a to b, u dv by dx, so this is going to be uv a to b minus integration a to b v du by dx. So that's what you have to do. And how do you select u? U is selected by LATE, by this order. L represents log or ln, algebra A for A, T for trigonometry, and E for exponential. So in our sum, if you take a look at that, LATE, so exponential is at the end, E, so A is algebra, so U has to be this. So let's start the sum. So we can write, first of all, let's do one thing. Let's take volume equals to pi I. Let's take this integral as I, because it's easier to write it if we write it as I. So I equals to uv. So we know what u is. U is x squared. So this is u. Now v represents dv by dx. Remember, if one is u, the other one is dv by dx. So that means if dv by dx is what we know, therefore v is going to be integration of that thing. So that's the rule, that's the fundamental rule of calculus. So if v is e to the power 2x, then in this particular sum, if dv by dx is e to the power 2x, in this particular sum, integration of e to the power 2x is going to be e to the power 2x divided by 2. That's the rule for integration for exponential function. It is unchanged, but the chain rule is going to be divided by 2. So limit is 1 to 3 minus integration 1 to 3, that's the limit, 1 to 3. V is going to be again e to the power 2x divided by 2, and du by dx, the derivative of u, the derivative of x squared, is going to be twice x. So dx. So this 2 and this 2 cancels. So if we put the limit, it would be 3 square e to the power 2 into 3 by 2 minus 1 squared e to the power 2 into 1 by 2. Now what we can write here is 1 to 3 x e to the power 2x dx. So this is one more time we have to do integration by parts. So this is 9 by 2 e to the power 6 minus this is e to the power 2 by 2. So this is this minus, let's do integration by parts again. Now let me put a big bracket here because we are doing integration by parts again. So LATE, u is going to be x, so this is uv, so u is x, v is going to be the integral, since this is dv by dx, so e to the power 2x equals to dv by dx, so integration of that is going to be e to the power 2x by 2, the limit is 1 to 3 minus integration limit 1 to 3, v is going to be e to the power 2x by 2, and du by dx is going to be derivative of x, it's going to be 1. So that means 9 by 2 e to the power 6 minus 1 by 2 e to the power 2 minus, now we can put the value here 3, so this would be 3 e to the power 2 into 3 by 2 minus 1 e to the power 2 into 1 by 2. So that is the limit from 1 to 3 here. Then minus, if we do the integral here, e to the power 2x by 2 is going to be e to the power 2x by 2, and there is another 2 here, so this would be 4, and the limit would be 1 to 3. Okay, so this is going to be 9 by 2 e to the power 6 minus 1 by 2 e to the power 2 minus, let me keep the bracket here, this would be 3 by 2 e to the power 6 minus 1 by 2 e to the power 2 minus, now we need the bracket here, if I put 3 here, this would be 1 by 4 e to the power 2 3 is 6, then minus, if I put 1 here, 1 by 4 e to the power 2. Okay, be careful about the brackets. So this would be 9 by 2 e to the power 6 minus 1 by 2 e to the power 2 minus 3 by 2 e to the power 6 minus 1 by 2 e to the power 2 minus 1 by 4 e to the power 6 minus 1 by 4 minus minus will become plus e to the power 2. Okay, now let me scroll down and finish it off. So this would be 9 by 2 e to the power 6 minus 1 by 2 e to the power 2 minus 3 by 2 e to the power 6 minus minus plus 1 by 2 e to the power 2 plus 1 by 4 e to the power 6 minus 1 by 4 e to the power 2. So this minus and this plus cancels, and so the remaining is going to be, if I take e to the power 6 common from this 3, it would be 9 by 2 minus 3 by 2 plus 1 by 4 e to the power 6, and there's only 1 e to the power 2, which is 1 by 4 e to the power 2. So 9 by 2 minus 3 by 2 plus 1 by 4 is going to be 13 by 4. So this is 13 by 4 e to the power 6 minus 1 by 4 e to the power 2. So remember, the volume was pi I, so volume equals to pi, and instead of I am putting 13 by 4 e to the power 6 minus 1 by 4 e to the power 2. So that's the volume. Question number 57 says we have a region and we have to find the area of the region. This is Cartesian. Area equals to limit 0 to 2 pi and y dx. So y is 3 sine x by 2 dx. This is pretty straightforward. So integration of sine theta by the fundamental rule of calculus is 3 would be 3. This would be minus cos theta. And by the chain rule, derivative of the angle half x is going to be half. And the limit is going to be 0 to 2 pi. So this means we can write 3 divided by half is going to be 6. So minus 6 cos pi by 2, 0 to 2 pi. If I put the limit, so 2 pi would be minus 6 cos 2 pi by 2 minus 6 cos 0 by 2 is going to be 0. So this 2 cancels, cos pi, so minus 6 cos pi is minus 1 minus cos 0 is 1. Remember from C2, cos 0 is 1 and cos pi is minus 1. So 6 minus plus 6 equals to 12. That's the area. This is question number A. In question number B, we have to find the volume generated by the solid in case this is rotated on the x-axis. Remember, volume is solid space and this needs to be rotated for making it a solid space. So volume equals to limit 0 to 2 pi y square dx. So if I bring the pi outside, 0 to 2 pi, y is going to be 3 sine theta is x by 2 whole square dx. This would be pi 0 to 2 pi 9 sine theta whole square is sine square theta x by 2 dx. We can just bring the 9 constant outside. This would be 9 pi 0 to 2 pi. Now sine square theta, you remember while integrating sine square theta we use an identity and then we use the fundamental rule of calculus, and this is the identity. Cos 2 theta is 1 minus 2 sine square theta. So we can write 2 sine square theta is 1 minus cos 2 theta. Therefore we can write sine square theta is 1 minus cos 2 theta divided by 2. So this is the identity that we can use for that particular sum. So we can write half 1 minus cos 2 theta, meaning 2 of x by 2. Remember, this was already x by 2, so this is theta, so 2 theta means 2 of x by 2, and divided by 2 is the same as multiplied by half. From here we can write 9 by 2 pi, I'm bringing this constant outside as well, integration of 0 to 2 pi 1 minus cos x dx. So remember, this 2 and this 2 cancels and we get that. So next we get 9 by 2 pi, integration of 1 is x, minus integration of cos x is sin x, divided by chain rule is 1, so I'm not writing that. So 0 to 2 pi, so this would be 9 pi by 2. If you put 2 pi here, it would be 2 pi minus sine 2 pi, minus, if you put here, it will be 0 minus sine 0 is 0. So it would be 9 pi by 2, 2 pi minus sine 2 pi means sine 360 degree, this is 0. So this would be 9 pi by 2 into 2 pi. So this 2 and 2 cancel, this would be 9 pi squared. Question number 58 is a by-part sum. Let me review. When we have an integration by parts, limit a to b u dv by dx. So you have to write the formula uv limit a to b minus integration a to b v du by dx of dx. That means u equals to late. So that's how you organize. L for log. Log gets the most priority. Second priority is algebra. Third priority is trigonometry. And the fourth priority is the exponential function. And the remaining one is dv by dx, and you get v by integrating whatever is there. That's how you do the sum. Let me do the sum in detail, how this is done. So the first thing you do is you have this integration 1 2 3 x square ln x. Let me call this I. So u would be by late ln x. Therefore du by dx is going to be 1 by x. Remember, we need a du by dx in the formula, so I'm finding it before. And so the remaining dv by dx is going to be x squared. Here the order is not important, the ordering of late is important. So v is going to be integration of x squared dx, which is going to be x cubed by 3. Although this is an indefinite integral, until the sum is done we don't put a plus sign, and besides the actual sum is definite integral, so we do not have to put a plus sign. It will be a numeric answer. Since we know the value of u, value of du by dx, and we know the value of v, so that means we can plug it in. So therefore I can write I equals to uv, that means ln x, and v is x cubed by 3, limit is 1 to 3, minus limit is 1 to 3, v is x cubed by 3 into du by dx is 1 by x dx. So that means I equals to, if I put the value of the limit 3, this would be ln 3, and if I put this 3 here, 3 cubed by 3, 3 cubed by 3, minus, if I put 1 here, ln 1 is 0, so the whole thing would be 0, so I'm not writing anything else, minus integration of 1 to 3. So if you divide x cubed with x, it will be x squared, so this will be x squared by 3 dx. So this would be 9 cube, 3 cube is 27 by 3, that means 9, so 9 ln 3 minus, now integration of x squared is x cubed by 3, and we already had a 3 before, so this would be 9, so 1 to 3 is the limit, so 9 ln 3 minus, this is going to be 3 cubed by 9 minus 1 cubed by 9, that means 9 ln 3 minus 3 cube is 27, 27 by 9 is 3, minus 1 by 9, so this would be 9 3s are 27 minus 1 26, so 9 ln 3 minus 26 by 9 is the integral.